Hi, class. Let's take a look at the small intestine. Now, the small intestine is this long tubular organ, and it's located between the stomach and between the large intestine. So when I do SI, it's large intestine. When I do SI, it's small intestine. When I do LI, it's large intestine. So the small intestine is about almost 20 feet long, right? 19.7 feet long. It's about 1.5 inches in diameter. And there's three sections of it. We have the duodenum, the jejunum, and the ileum. And that would be from proximal to distal. So if we look at it this way, the three different colors here, here's the duodenum, there's your first portion. It's like the first 10 inches or so. Then you have the second portion, and then here's the ileum. When we talked about the stomach, remember we said the stomach produces intrinsic factor plus B12. B12 can join intrinsic factor in the presence of hydrochloric acid in the stomach, and it's going to move that B12 right here. This is where the absorption actually takes place, right in that ileocecal region, right in here. So you have duodenum, jejunum, and ileum. The other part here that's cut, this part is the large intestine. And just think of it as esophagus, stomach, small intestine, okay? And then what at the end of the small intestine right here, there's a picture frame that's going to frame in the small intestine. So the small intestine's here, and around it is the large intestine. And food goes up this way, goes across this way, and goes down this way. So they call that the ascending colon, transverse colon, descending colon. In the middle is the small intestine. So the duodenum is about the first 10 inches. The jejunum is about 8 feet. And then the ileum is the final segment that's about 11 and a half feet long. And it ends where we have a region called the ileocecal valve. It's where the ileum and the cecum meet. So if I go back here, let me just remove. If I go here, this is the ileum. That's the end of the ileum. This part of the large intestine right here is the cecum. So right between the ileum and the cecum is an ileocecal valve, and this is the ileocecal region. Okay, and this little extension right here is the appendix. Now, what's really cool about the intestines, this is where the majority of your food is going to be absorbed. So when we look at a portion of the stomach, right, we have this plica circularis, which looks like how a nut goes on a screw, right? You have these like spiral grooves in here. In these spiral grooves, if we to take this section, we have these grooves that go up and down, up and down, up and down, which is needed to help spin the food. As food is going through here, remember, we do have enzymes produced by the intestines. And we don't want the enzymes just to work on the food from the outsides, right? So think of this as like whatever's going through here is like ground beef. What's on the outside can go on the inside. What's on the inside can go on the outside. As the food is moving through here, it spins. It kind of evenly distributes the digestive enzymes through whatever food is going through here. That's why you got these spiral grooves. Otherwise, the digestive enzymes would only work on the outer perimeters of whatever the food is. So as it's spinning it, the enzymes are working on the inside, it's working on the outside to help break it down. The villi are the sponges, and in each villi, right here is a single villus. So right here is a single villus. Look what we have. We have arterioles, we have venules, and we have lacteals. So right at the tip here, this is where those little villi are. And these are the epithelial cells. So remember when I spoke about leaky gut syndrome or intestinal permeability? If these tight junctions are damaged, the foods can pass through here, the proteins can pass through larger than what they should, and that's when the body makes antibodies and attacks it. Okay. Otherwise, when it's nice and healthy, like here, we have these healthy, simple columnar cells. Nutrients like your water soluble vitamins can go into the arterial system, whereas your fat soluble vitamins, like vitamin A, D, E, K, CoQ10, these are all like fat soluble, they enter into lacteal system. What does lacteal mean? Think of lactation, milky, fatty, white, fatty, milky substance. So all the fat soluble stuff goes into the lacteals. When people have celiac disease, this is when we have damage to this, right? Gluten starts to damage these epithelial cells and you start to get malabsorption diseases. Okay. So what are the plica circularis? The plica circularis right here in these pictures, right in here, these grooves, they're spiral grooves. They're spiral folds. And they're located in the small intestine, and it increases the surface area of the small intestine, but it causes this chyme to spiral and mix as it travels through, allowing for all of the digestive enzymes to go through it more uniformly to properly digest it and to be completely absorbed. So it's extremely important. This is what the plica circularis actually looks like in a dissected small intestine. It's pretty neat. Here's what it looks like again, right? So it's creates a nice um, uniform flow so the digestive enzymes can go inside and outside. The microvilli, those are those small folds that are on top of the villus. Okay, and the folds increase the surface area, and that's what really allows for the digestion and absorption of the nutrients about 24 times. Okay, microvilli are important. So the function of the small intestine, that's where the majority of your digestion and absorption are going to be taking place. And the intestines also produce intestinal juice. Although most of the juices in the intestines come from the pancreas, the intestines also produce it. So the intestinal juice, we have mucus in there produced by the Brunner's glands. We have enzymes that are produced at the crypts of lubricans, which are located in the valleys, right? If you have these things going up and down, the crypts are in the valleys, right? These would be like the villus and the microvilli on top of them. So the crypts of lubricans are located kind of like down in here, and they're highly rich in something called mast cells. And mast cells produce histamine. And what happens if a person has a histamine reaction? They get all nose, they get nasal, right? They start talking like this, right? Their nose gets congested. That's a histamine reaction. And you get itchy skin, right? You get red, itchy skin, and you get like congested, and you could run to the bathroom. So it's no wonder why when people put something in their body that doesn't belong, that they're allergic to, like dairy, peanuts, the mast cells produce histamine. They have a histamine reaction that doesn't just affect the gut, but it affects the skin. They get itchy ears, itchy scalp, itchy skin. They get a congested nose. They get all sinusy, and then they have to run to the bathroom. So the majority of the digestive enzymes in the small intestine, they are produced by the pancreas, and they travel to the small intestine by the pancreatic duct to the small intestine. But the intestines also produce carbohydrates, lipases, and proteases. So the pancreas produces them, and so does the intestines. They're just called intestinal carbohydrates, intestinal lipase, intestinal protease. Remember, anything that ends in ase is an enzyme. So protease breaks down proteins, lipases break down lipids, which are fats. Carbohydrates break down carbohydrates. In intestinal juice, there's water, there's electrolytes, and there's even a hormone called cholecystokinin or CCK. And what does CCK do? Well, what happens is when there's fat that goes from the esophagus into the stomach, then it goes into the duodenum. So when there's fat that's in the stomach and it goes into the duodenum, let's say here's the liver, we'll put an L for liver, and then right here is the gallbladder. The duodenum produces CCK. The CCK makes the gallbladder contract, and the gallbladder releases bile that goes into the duodenum. And what is bile? Bile is a fat emulsifier, meaning it breaks down fat. But the bile is produced by the liver. So the liver makes the bile, it stores it in the gallbladder. When there's fat in the stomach that goes to the duodenum goes, hey, you got fat in here, need some help to break me down. So it releases cholecystokinin, CCK, to go to the gallbladder. The gallbladder contracts and pushes out the bile that the liver made. The bile helps to break down fat. But you know what else happens that's really neat? Is that the gallbladder just doesn't have bile, it has calcium, it's got toxins, it's got cholesterol, it's got phospholipids. So every time the gallbladder contracts, all of these things, the bile, the calcium, the toxins, the cholesterol, and phospholipids, go in the small intestine. So when you have toxins and cholesterol that are in the intestines, anything that's in the intestines can be reabsorbed into circulation. The body doesn't want to reabsorb it. You want to get rid of it. And that's why fiber in your diet is so important, because when you eat fiber, it gets rid of toxins and cholesterol through healthy bowel movements. Otherwise, you reabsorb it. Okay. And the phospholipids work in conjunction with bile to break down the fats. The phospholipids also help with fat breakdown. Now, check this out. Let's say you're eating foods that you're allergic to, that don't belong in your system. The epithelium of the duodenum break down. So now when there's fat that comes in there, the epithelium of the duodenum can't recognize it to send the signal of CCK to the gallbladder. If you're not producing the messenger to go to the gallbladder to make it contract, whatever's in the gallbladder stagnates. It's in here like a river or a lake that's not moving. So if you have bile and you have water and you have calcium and toxins and cholesterol in the gallbladder and it's not contracting and flushing it out, whatever's in the gallbladder stagnates. When you get calcium, toxins, and cholesterol, you're going to get a stone. It's called a gallstone. All right. So one of the causes of gallstones, people don't really consider it very much, but it's a huge thing, is that the gallbladder is not contracting because there's damage to the duodenum, because the person's putting things in that should not be in their system, damaging the intestines. Okay, duodenal ulcer. Duodenal ulcer, that's when you get erosion of the duodenal tissue. And duodenal ulcers are about 4 times more common than gastric ulcers. All right, but still a similar concept. It's breaking through the mucosa and the submucosa and the muscularis, and you got a lot of nerve endings and blood vessels down here. So when they look at blood, when they see, oh my gosh, they're losing iron, there's blood loss, there's probably an ulcer somewhere, they have to find it. So they do either an upper GI series and they put the camera down through the esophagus into the stomach, or they'll go through the lower end, through the anus and rectum, and see if there's any ulcers at the lower end. So here is the duodenum, here's the pancreas, and here's the liver. And in the next video, I'm going to come back and I want to talk about these things in more detail.